Alright, today we're going to start by looking at the 1-5 vocab. 1-5 is solving equations and inequalities by graphing. So our directions on the vocabulary say to draw a line from the algebraic equation or inequality in column A to the graph that may be used to represent it. Instead of drawing lines, y'all good with just writing the letters underneath the equations? Alright. So the first one says we've got a plus bx. When I see something like that, a plus bx, it only has one x in it, I automatically think to myself that it's going to be a linear equation. So for it to be a linear equation means it's going to be a straight line, correct? All right, but then on the other side of the equal sign, we say equals c. C usually stands for a constant, so that just means it equals a number, right? So that's going to be a straight line. It's not going to be diagonal. It could be, it's more than likely going to be a horizontal line. So if I look at all of my graphs here, I'm looking basically for two straight lines. Let's see, yep, E. Do you see how one of them is horizontal, one of them is diagonal? So one would be a good example for, or E would be a good example for one. All right, number two, we've got the absolute value of x plus a. So the left side tells me I'm going to have what type of graph? Not a U, but it's going to look like a V. A V. Absolute value looks like a V. And then bx plus c, again, tells me that's going to be a straight line. So do we see a V in a straight line somewhere? C. Let's look at C. How many times do these two graphs intersect? Twice, right? So how many solutions does that mean it has? Two. If I were to go back to E, how many times does that intersect? Once. So that means we would only have one solution, right? All right, we're going to skip 4 and 5 just for a second. 3 and 4, we'll come back to them. But ax squared plus bx plus c, this is number 5. The ax squared tells me that it's going to be a quadratic, which is a what type shape? A parabola or a U shape, correct? All right, so there's going to be two graphs. One of them's going to be a parabola or U shaped, and the other one's going to be the absolute value of x plus d. So that means it's going to be what shaped? V shaped. So which letter is that? B. And on B, how many solutions do we have? 2. Intersects twice. All right, the way your paper is shaded versus mine is why I wanted to kind of come back to 3 and 4. This says ax squared plus bx plus c is greater than 0. So what that means is it wants the shaded regions. It wants to know which parabola has positive values that are above the x-axis. Well, I think from what I can gather best is they were trying to make these lines right here look like the shaded, okay? So they want to know, for number 3, they want to know whether it's A or D, which one has values above the x-axis that are shaded. A. And the values below the x-axis that are shaded would be D. That's what I gathered from it. You would think it would be the opposite. You would think that the darker part would be the shading, but I think they were saying something else. All right, E, C, A, D, B. Y'all good with that? All right, because of our time, I'm going to skip over this. If we have time, I may come back to it. Doesn't have just a whole lot to do with our lesson today, so I'm just going to go straight into our examples. Y'all okay with that? All right, so example 1 says, how can you use a graph to solve an equation? An equation is a statement that two expressions are equal. The values of x that make this equation true are the solutions. To solve an equation by graphing, write two new equations by setting y equal to each original equation. Graph the two equations and identify the points of intersection. These points will have x values that produce the same y values for both expressions. Each of the x values is a solution to the original equation. So they show you how they graph the two different ones and how many times did these two intersect. These two graphs. Only once. They intersected right here. It says, so negative 3x plus 20 is equal to 5 when x is equal to 5. This is the only point on the graph where the value of the functions y is equal to negative 3x plus 20 and y is equal to 5 are equal. And then they give us two other equations. The absolute value of x minus 4 is equal to 1/2 x plus 1. Write it again as two equations, which they did. And it says that they appear to have how many intersections? 1, 2, right? So it says it appears that y is equal to the absolute value of x minus 4 and y is equal to 1/2 x plus 1 intersected x is equal to 2 and x is equal to 10. The solutions to the equation, so this is what I wrote in my margin by example 1. As I wrote my equation, the absolute value of x minus 4 is equal to 1/2 x plus 1. It tells me that my solutions are x is equal to 2 and x is equal to 10. You can verify these values by substituting them back into the original equation. You can do that to make sure you got your correct answer. So I'm going to show you how you would substitute them back into the original equation. We'd let x equal 2, so the absolute value of 2 minus 4 should be equal to 1/2 times 2 plus 1. What's 2 minus 4? Negative 2. The absolute value of negative 2 is what? Positive 2. This cancels out and leaves me with 1 plus 1, which is 2. So is 2 an answer to our equation? Yes. And then we would do the same for 10. We would plug 10 in for x. So 10 minus 4 is equal to 1/2 times 10 plus 1. The absolute value of 6 is just 6. 1/2 times 10 is 5, and 5 plus 1 is also 6. So both x is equal to 2 and x is equal to 10 are solutions. You can, like I said, you can double check your answers by just plugging them back into the original equations. So now we are going to try to graph to solve our equations. I know your graph doesn't have any lines yet, so I want you to go ahead and draw the lines on the graph for me. Alright, so like they just told us in our directions, we need to write it as two separate equations. So I've got y is equal to 5x minus 12, and I'm going to graph it. You could put it in your calculator, but I'm going to help save us some time. The first point we could plot on here is at 2, negative 2. Then we go up 5, 1, 2, 3, 4, 5 over 1. So I have 2, negative 2, and then I went up 5 over 1, up 5 over 1. I went up 5 because we couldn't start at the y-intercept.
Third lunch dine-in, please report to the cafeteria. It is a blue day. Thank you.
Instead of to save us time from putting it in the calculator. All right, then my next equation is going to be at y is equal to 3. So 1, 2, 3 is going to be this line right here. So how many times do these two lines intersect? Once. That means I only have one solution. So what is my solution? X equals 1, 2, 3 is right. If you wanted to plug it in, you could to make sure it was correct. 3 does equal 3. Yeah, but they just wanted you to solve it by graphing. But yeah, if you solved it algebraically, you would get the same thing. All right, for B, we wrote it as two separate equations. We'd have y is equal to negative absolute value of x minus 2. So that means we move right 2 units and we have a reflection across that x-axis, if you remember that from last week. So our absolute value graph would look something like this. All right, our second equation is going to be y is equal to negative 1/2 x minus 2. So that tells me I've got a y-intercept at negative 2, which is on our graph, and then I can either go up 1 and left 2, or down 1, right 2, to figure out where I may intersect at. How many times do these two graphs intersect? Twice. At x equals, what's that first one at? X equals what? 0, and the second one is at x equals 8. Everybody good with using the graph to solve an equation? All right. Next example says, how can you use a graph to solve an inequality? They tell us to solve x squared minus 4 is greater than 0. To solve the inequality, identify the values of x that make the value of the expression x squared minus 4 greater than 0. Graph the equation y is equal to x squared minus 4 by translating the parent function down 4 units. Little hint they gave us, look for the points on the graph where the function is positive. So when they're greater than 0, so do you see how they did that? Because it said greater than 0 right here. And the intercepts appear to be at x is equal to 2 and x is equal to negative 2. The graph of the function is positive over the intervals negative infinity to negative 2, so that's the left side, and 2 to positive infinity. So it says, so x squared minus 4 is greater than 0 when x is less than negative 2, so that tells us right here, because it's all the values less than negative 2, or when x is greater than 2. So let's take a look at our equation. It says use a graph to solve each inequality. So we're going to graph this inequality. I'm going to tell you the points. We've got a vertex, or let's first just start with this point. We got a point at negative 5, 0. I'll give you a second. I forgot y'all haven't drawn these lines yet. All right, so we've got a point at negative 5, 0. Got a point at negative 4, negative 3. I've got a point at negative 3, negative 4. So that's our vertex actually, and then we go back up. And we've got 3 more points. How did I get? Just because I put it in the calculator earlier. Yeah. So she asked me how I got that, and it was just from putting in the calculator earlier and getting the tables. I'm just trying to save us a little bit of time. So this says x squared plus 6x plus 5 is greater than or equal to 0. So we need values that are positive, and they need to be, because they need to be greater than or equal to 0. So do y'all see how I figured out what was positive? It's what's above the x-axis, right? So what's above the x-axis for me is from negative infinity, the interval from negative infinity to negative 5, and from negative 1 through positive infinity. Do y'all know how I got that? This arrow tells me that it's going to keep going to negative infinity, okay? And this is at negative 1, 2, 3, 4, 5. So that's how I got the first one. I knew that it was a bracket because of this sign right here, okay? And then we picked back up at negative 1, and we're going until positive infinity. So we don't want to keep it like this. We need to write it in a different form. We need to write, this is in interval notation, and we need it in inequality notation. So this is saying all the values that are less than or equal to negative 5, right? So we would write x is going to be less than or equal to negative 5, or x has to be what? Greater than or equal to negative 1. All right, part B. X plus 3 tells me that I have an x-intercept or a y-intercept at 3. 1, 2, 3, and a slope of 1. And my next equation tells me that I've got a y-intercept at 7 and a slope of negative 3. How many times do these two graphs intersect? Once at x is what? Equal to 1, but we're not dealing with equals, we're dealing with inequalities, right? So we're going to say x is greater than 1. All right, moving on to examples 3 and 4. We're going to work them the same way. What they tell us to do is use a table to solve an equation. So basically we could do that, but do you see how they start going into decimals? And does our table show any decimals anywhere? No, it doesn't. So what we are going to have to do is we are going to just use that feature that's on our calculator that will tell us what the x value is of our point of intersection. Are y'all okay with that? All right, it says the equation x squared minus 4x plus 1 is equal to x minus 2 has a second solution in the interval 4 is less than x, which is less than 5. Use a spreadsheet which we're not going to use a spreadsheet, we're going to use our calculator to approximate this solution to the nearest thousandth. If you don't know what that is 3 decimal places. And I don't know about you, but sometimes rounding decimals can be a little bit difficult for some people. You forget if you need to round up or round down or whatever. So I'm going to show you this trick on your calculator that you can use. I want everybody to hit second plus 712 to make sure it's cleared out. And then we're going to hit the mode button. We're going to go down to where it says float and over to the number 3 and hit enter. Now we go to y equals, and we're going to put the left side in y1, so x squared minus 4x plus 1. And the right side in y2, which was x minus 2. All right, and then I don't know if you remember or not, but we're going to hit second, trace 5. Second, trace 5. How many points of intersection does this have? 2. It's going to ask you, is this the first curve? Yes, and it should jump down to the next curve. Then you hit enter twice, and it tells you, and it should round automatically to 3 decimal points. And it should tell you what the x value is at that intersection. So I'm going to write x is approximately, because that's not exact, 0.697. That's one of our points of intersection. All right, now we need to go over to the other point of intersection. So second, trace 5 again. But I need to make sure I'm closer to that other intersection before I hit all these enters. And that should give you another x value of 4.303. Well, let's go back and look at our directions. It says that the equation has a second solution in the interval of x is between 4 and 5. So is that going to be our first intersection we found? Our first solution we found? No, that's not between 4 and 5, is it? But is our second one? Yes, so that's our answer for 3. All right, the next one we're going to do it the same way, except this time it tells us to round to the nearest tenth. How many decimal places is it to round to the nearest tenth? 1 decimal place. So if you want to go back to mode and change mode to, or go to float and then go to the number 1, that should take you to 1 decimal place. Put the left side in Y1 and the right side in Y2. And this time we want to find both of these solutions. We're not just trying to find one across an interval. We want to find both of the solutions. So y equals x squared plus 2x minus 1. And do y'all remember how to do the absolute values? If not, it's alpha, window, enter. X plus 2 plus 2. Second trace 5. So I go close to 1 intersection, and I get x is equal to negative 3.3. Not equal. We're going to say approximately negative 3.3 because we're doing some rounding. And second trace 5. Go to the other side. And I got approximately 1.8. So x is approximately 1.8. Alright, so the next page we have our do you understand and do you know how. It's only 4 questions, so that's not too much for you tonight. And you may could finish it before the bell rings today, actually.